previous video, we learned about how to find inverse of 2 by 2 matrix. So for today, we are going to look at the inverse of 3 by 3 matrix. So we have a question on the board. We have inverse of, so there is a 3 by 3 matrix and you're supposed to find the inverse. So the notation for inverse is A exponent negative 1. So that's the A inverse. And A inverse. We have a formula to find the inverse of any matrix. So we have the formula to be 1 over the determinant of the name of the matrix. So this is A. So when the matrix is B, use B. Whatever notation you use that name. Multiplied by the adjoint of matrix A. So we are supposed to do this step by step. So first we need to find the determinant of this matrix. So we write that A equal to, so over here I have 1, 2, 3, 1, negative 3, 1, negative 1, 4, 2. So if you want to find the determinant of 3 by 3 matrix without using a minor and cofactor strategy, we have a shortcut strategy to do so. This is how it is. You are supposed to repeat the first two columns at this side to form part of the matrix. So we have this 1, 2, 3, 1, negative 3, 1. Then we find all the left diagonals. Then we write the answers and also the right diagonal. So over here, our left diagonal, the first one is this. Multiply all the numbers then. This times this, that will be negative 3. Negative 3 times 2 give you negative 6. Coming to the second left diagonal, that is everything here is positive 12, so plus 12. And when we come here, we have negative 1 times 2, negative 2 times 1, it will give you negative 2. So negative 2. So we find the answer to this. So this will give you positive 6 minus 2, that will give you positive 4. Alright, so we do the same strategy for the right diagonal. So this one we multiply. So 1 times 2 times 2 give you positive 4. Then we come to the next one. 1 times 4 times 4 also give you positive 4. Then the last one, negative 1 times negative 3, positive 3 times 9. That will give you positive 9. Alright, so this one will also give us 17. We have 17. Alright, so the determinant will be, so the determinant of A will be, so we're going to find the difference of the right and the left diagonals answers. Starting with the left diagonal, we had 14, so we write that one first, minus the sum of the right diagonal is 17. And our determinant will give you negative 13. So this is the answer for the determinant of this 3 by 3 matrix. We need to find the adjoints. So let's proceed and do the adjoint. So adjoint of this 3 by 3 matrix, we need to repeat this matrix. After repeating the matrix, repeat the first 2 rows over here. So after repeating the first 2 rows, then repeat the first 2 columns at this side. Then we delete the first row and the first column from this matrix. You can see we have 4 by 4 matrix in the middle. So we need to rewrite this 4 by 4 matrix. So after the 4 by 4 matrix, we need to create 2 by 2 matrix from this 4 by 4 matrix to get our adjoint. So this will be our first 2 by 2 matrix, and negative 3 times 2, that will give you negative 6, and this time this will give you 4. So in this case, we have the first number is negative 10. Then is another 2 by 2 matrix, negative 1, 2. And we have negative 3. There is another 2 by 2 matrix. So we have 4 minus 3. So if you could have noticed, the 2 by 2 determinants of this 2 by 2 matrix are the column form, as the written 8 answers are the row form to the adjoint. So that's the shortest way, because if you could have written these answers also at the column side, after that we need to transpose the matrix again before you can get the adjoint. So we need to skip that. So that's the strategy. So as I'm doing here, we are already transposing it. So let's continue. This and this is another 2 by 2 matrix. So this and this will give you 12, and this will give you 4. So we are going to get 8. Another 2 by 2 matrix. So we have 2. This and this is negative 3. So we have positive 3, and that will give you 5. We have this and this, which is negative 2, 4. That will give you negative 6. Another 2 by 2 matrix. This and this will give you negative 9, so to positive 9, and that will give you 11. Another 2 by 2. So we have 3. This is 1. So positive 2. And the last one, another 2 by 2. Negative 3. So that will give you negative 5. So now we have our adjoint, we have our determinant. So we can get the inverse using the formula. So the inverse, so 1 over the determinant, and determinant, so what's 1 over the determinant? Negative 18. Then multiply by the adjoint. So the adjoint is here, negative 10, negative 3, 1. 8, 5, negative 6, 11, 2, negative 5. So the final answer for adjoint. So most need to answer in this form, but the final answer will be like this. We multiply each number in the matrix against a fraction here, 1 over negative 13. So we have this to be, when this multiply this, we are going to get 13 over 3. Yes, because the negative are going to cancel out. So 13 over 3. So for this side, we have negative 8 over 13. For this side, we have negative 11 over 13. For this side, we have 3 over 13. The negatives will cancel out. Then for this, we have negative 5 over 13. For this, we have negative 2 over 13. For this, we have negative 1 over 13. Then we have positive 6 over 13. And the last one, positive 5 over 13. Now, this becomes the final answer for the inverse of this matrix, and it is 3 by 3 matrix. Alright, so that is a strategy on how to find the inverse of 3 by 3 matrix. Thank you very much for watching. Don't forget to comment, follow, and like my videos. Visit YouTube, my YouTube channel, and search for GH Mathematics Doctor and subscribe to my channel. Thank you for watching.